Hello everybody, you're very welcome to this episode of Programming and Algorithms. In this episode we're going to look at how to connect to external databases from Python, which is really handy because you can't really do much without being able to access a database. So in this particular lesson we're going to look at how to connect to a database called MySQL. And that's a specific kind of database. There's lots of them out there. We'll look at a few of them later on. And what we're going to do is just see how to connect and how to ask the database for a list of values. So let's talk about what databases are for a minute first. I'm sure everybody has a rough idea if we think about student records or patient records or records where you've got a lot of detail and there's lots and lots of them. It's that kind of thing. That's what a database is. There's rows and rows and columns of data. So a database is, as they say, structured to allow for easy access, and you have various kinds. MySQL, as I mentioned, there's something called Postgres, or PostgreSQL, sometimes called or PostgreSQL. Microsoft has two databases. One is called SQL Server. The other is Access is kind of being faded away. And then Oracle, which is the most popular database system commercially at the moment. So just to explain the rationale or why we need databases, let's imagine that we were going to store information about students in a notepad file. Okay, so every time a student joins, we don't stick it in a database, we put it in a notepad file. What does that look like? So here we go, here's a notepad file. Jane Smith was the first student to join, her student number is that. She joined at such a date. John Smith was the second student, his student number is that, he joined at such a different date. Joe Smith was another student and she joined at such a date. And then Joe Smith, male, was another student, I'm not sure of his number, and he joined at such a date. We can see that the information is all there that we need about the students, but it's possibly a bit awkwardly structured. So let's think about it. If I have to search for the name Joe Smith, so if I want to find out when Joe Smith joined, Joe with an E, what I'm going to do is write a program to probably look at one character at a time. And if I find the character J, then I'll look if the next letter is O, and if the next letter is E, and then the next is space, the next is SMITH. So let's look at that simulated. Here's what happens doing the search. We're looking for Joe Smith. It goes across the first line, goes across the next line. It keeps searching until it finds the name Joe Smith. So it has to search what we call sequentially, that is one after another, after another, after another, until it finds the name Joe Smith, and then it stops. That serial or sequential search is very inefficient because you have to look at each character, whereas with the database you don't need to do that. So let's think about that. There's also an issue about the consistency of the way the data is being recorded. So some data is formatted different from others. Let's look at an example. So we can see with the dates, in the first one it's day / month / year. In the next it's 10th of September 2013. Next it's day, month, year again, and the last one is 1st of September. So if I want to write a program to find out what students joined in September, I'd have to say look for numbers that have 09, look for words that have the word September, and look for words that have the word sept, S-E-P-T, full stop, maybe S-E-P-T, no full stop as well. There's a million different options as to how somebody can express a date, really. So with the database, we're saying keep it consistent by having just one way of looking at stuff. What other inconsistencies are there? Well, in the first three records for Jane, John, and Joe, we use the word student number to indicate where their student number is, whereas the last one we just said the word number. So again, if I'm typing in 1,000 students registering, sometimes I'm going to forget to put in a word or two, and I'm just going to say his number is instead of his student number is. So if I'm looking for people's student numbers using a program, and I'm using the phrase student number to find it, that's not going to work. Another inconsistency, I guess, is, well, it's not really an inconsistency as much as the fact that for the first three students, we know their student number. For the last one, we've put in the phrase open angle bracket, not sure. Sometimes we might leave it blank, sometimes we might say yet to be filled in, sometimes we might say that student doesn't have a student number. So just to have a consistent thing we can stick in when we don't know what the student number is. Also here, and just as an example, I've said the first three students are the first, second, and third. And then like I lost count somewhere, so I just put in that Joe is another student. So again, if I was trying to count the number of students, this wouldn't work. So if I'm somebody in registrations typing in all this information by hand, things will slip. That's just how it goes. Whereas if there's a way we can structure the data so that this never happens, that's better. So let's fix this information by sticking all the same information into a table as such. So now we have all the names of the students, Jane, John, Joe, and Joe, with their gender, female, male, female, and male, with the order in which they joined, 1, 2, 3, 4, with their student numbers, and the one we don't know we've left as a null value. And then we've said the dates are consistently in the format of day / month / year. So there's a lot of benefits we can see already to the consistency with the dates. We can see the order number, instead of being 1, 2, 3, another, it's 1, 2, 3, 4. We don't explicitly have gender in our notepad, but we do say her student number and his student number, so let's preserve that. I also note, and this is just a bugbear of mine, it's something that I always do, a lot of databases for name have first name, last name. I find that very annoying and very irrelevant. First name and last name doesn't make sense to me, because for me there are a lot of international students whose first name is their family name. So my name is Damien Gordon, but if I was in, let's say, China, Gordon would be my first name and Damien would be my family name. So rather than have first name, last name, which does not make sense, and I've seen it often happen in organizations where they assume because your first name goes first, they put it first, even though your first name could be your family name, they call people by the wrong name. So I think it's much clearer to say your family name and your given name. This is just a bugbear I have, it's nothing too serious. You can do first name, last name if you like, but I think this is much more clearer in terms of the design of our data, because then we'll always know, we'll address somebody by their given name, which may not be the same as their first name. Anyway, that's a minute detail that I always have a bugbear about. So with this table now, and we call it a table, we call the information, we say that there's columns, family name is a column, given name is a column, gender is a column, order number is a column, student number and date join. They're all columns of information going down, and each row across for Jane Smith, for John Smith, for Joe Smith, and for Joe Smith, we can call them rows or sometimes records, so each individual person's student record. Perfect. So as I said, we've eliminated the consistency problem. Instead of having first, second student, third student, and then another student, 1, 2, 3, 4 makes that clearer. And our date problem is fixed. Because when we create a database, if we say the only way you're allowed to insert data is dates is DD, MM, YYYYY, then the person typing this in has to put it in that format. So nobody will put in 10th of September 2014, they'll just put in 10/09/2014. So that makes things a lot easier. And in terms of our search, we saw before our serial search, we saw it was sequential, we had to read one word, one letter at a time. If we're searching for Joe Smith now, all we do is search straight down the column until we find where given name equals Joe and family name equals Smith, and that's it. So instead of having to go through every word across until we find Joe Smith, we just go straight down. So it's a much faster search. So that's useful. We'll also remember that the name of the table is student records. So we give these, and if we go back just for a second, student records there, we can see it on top, the name of the table. It's important to give these tables names because a database can have multiple tables in it. We might have student records, we might have student timetable, we might have lecturer records, we might have all kinds of module information. So in a single database we can have a lot of different tables, so each one has a name, and our one is called student records. Perfect, so now let's look at the programming language we need to program a database. So to create a database, there's a specific language, and it's called SQL or SQL. Created really in the early 70s. It's pronounced SQL, but there was already a software product called SQL, so they changed the spelling to SQL. There's loads and loads of different versions of SQL depending on the database you're using, but the format of the language is usually all the same. So just to remind ourselves what we're doing here, we're looking at how to connect Python to a database. So if we're doing that, we know the Python stuff a little bit already, and now we're looking at how to develop a database. So we build a database in SQL, and then we can use Python to connect to it. So let's look at the SQL programming language. If we look at our table again for a second, it's got family name, given name, gender, order number, student number, and date joined. If I want to find out all the student numbers from that table, my SQL statement is select student number from the table, student records. More generally, select field from a particular table. So if I say select student number from student records, it'll just list all of the student numbers in the table student records. If I only want some student numbers, though, I can say, let's say I just want the first 2 students to have joined the course. If I say select student number from records where the order number that they joined is less than 3, I'll just get order numbers 1 and 2, which is the first 2 students have joined. And our general form of that is select a particular field from a particular table where some conditions. And the conditions are exactly like Python conditions, order number less than 3. All right, let's look at how we set up a database. So if that's the basics of creating or selecting from the database. Before we think about the Python code again, let's think about how we set up the database. So we need to install a database on our computer. And then once we've installed it, we can start connecting to it. So to install MySQL, first we need to go to the MySQL webpage and http://dev.mysql.com/download/MySQL. We click on the download for the particular machine we're using, if it's Windows or Mac or whatever, and then we install it. Downloading it isn't necessarily a straightforward process. You normally have to create an account, log in, it asks you for some stuff, it'll send you an email to confirm your email, that good stuff. So even though I'm saying this in one sentence, download and install, there's a bit of work to be done in terms of doing this, but it's worth it because then you'll have a database sitting on your computer. When you then run MySQL, you're logged in with the username of root. With the database, it's the same as logging into an operating system. You need a username, and typically you're logged into the database management system as root. And part of the setup of MySQL will be to ask for a password, so keep it something simple like password, I'm saying, for the moment. If you're not happy with using the root login, you can create a new user simply by, once MySQL is set up, it'll give you a command window. If you type in the phrase create user, new user, let's say that's a username, then you've got a user called new user. Once we've got the database management system set up, we need to tell it what database we're going to use. So in our case, we're going to create a database from scratch. So again, when we're in the MySQL window, if we type the phrase create database and give it some name, let's say sample database, then we've told it we're in this specific database, because MySQL can have hundreds of different databases, each database which can have hundreds of different tables in it. And the next thing we need to do is just say use sample database. So we create a new database, then we say we're going to use this one to tell SQL this is the one we're using. Otherwise it doesn't know where to put the tables. So we're going to put all the tables we create in a database called SampleDB. Here's our SQL for creating our database. So create a table called student records. It has order number, as we saw, and that's a number. It's an integer that can be 3 characters at maximum, so that means any number from 0 to 999. Family name is a character variable, and it's at least maximum 20 characters long. Given name is a character variable, and it's at least 20 characters long. Gender, which we saw was either M or F, or C for cisexual, or whatever you want, or undeclared, or whatever U. We can just declare a variable of type character that's 1 letter long. For student number, because all student numbers start with a letter D or C, it's not a numeric type, it's not an integer type, it's a character type. And it's character type of length 8. And our join date is of type date. And then we open the bracket at the stop after the word student records, and we close it after the word date, and we terminate our create statement with a semicolon. So this is how we declare a table in SQL. We use the phrase create table, and then we declare all of the names of the columns in that table. And we describe each column, I think the same way we declare a variable. We just say what type it is and how long it can be. This is very important in databases because it needs to know the length of each character, each variable. Because if I asked, give me all the students whose gender is M, what it'll do is it'll say, well, for each record, the gender M is, we get there by jumping 3 plus 20 plus 20, and then we're on to the 1. So after 43 jumps, we're at gender. For each record, we just jump in 43 bytes, and then we're at the gender field. So that allows us to jump quickly to any location. If it's student number, it's going to be 44 bytes to jump in, because it's just 3 plus 20 plus 20 plus 1. So that allows us very quickly to hop around the table, as opposed to have to serially search each value. If we know the length of every field, we can just jump straight to where we're going to. So if I want to insert values into the table we've created, I say insert into the table student records the values 1 for order number, comma Smith for family name, comma Joan for given name, comma F for gender, comma student number is student number, and then the date is in the following format. So let's break that down. When we're inserting the values in, we don't need to restate which values are going into which variables or which columns, because the order in which we've declared the table, we have to stick the values in that same order. So we'll note that the order number is an integer type. So it's a 1, it's a numeric value that goes in there, whereas almost everything else is a string type or a char type. So it all has quotes. So Smith has quotes, Joan has quotes, female has quotes, and the student number. The date, though, is a special thing. To put in a particular date in SQL, typically what we do is we state the year, then the month, then the day. So it's 2013, September the 1st. You put it in single quotes, it will reformat it into 01/09/2013, even though you're inserting it that, but for SQL, this is the way to insert it. And here's the second one. We're inserting John Smith as order number 2, and he's a male, and he has that student number, and he joined on the 10th of September. Same year, same month, but the 1 is changed to a 10. So even though it's being put in as a string, the database will convert that into a date type, because we've stated it's a date type. And then if I say something like select all the fields, so star means all fields. We saw before we can do select student number from student records, that just prints the student number. But if we say select star, it means print out all the values in all the records. But essentially that command select star from student records means print out all the values in the table. And we'll see an example of that in a moment. Let's look at the Python code now, and this is very short. There's 2 bits to it. The first bit is to connect to the database. So to connect to the database, we use the standard Python library to import a library called MySQL.connector. Once we've imported it, then we create a connection by saying MySQL.connector.connect, and we connect to a particular database. First, we say what the host is. Where is it? So we can either say it's a database over on a network, and we specify some network somewhere else, or if it's on our current computer. Our current computer is called the local host. It's the local one. So when we say host equals localhost, it means look for a database on your computer that you're running at the moment. The database which we created, we called it SampleDB. So that's the specific database within the MySQL. The username is root because we didn't change it. And the password is password because we set the password as being password. So that's how we connect from a Python program to our database running on the local computer or local host with username, root, and password. And now the code to do a query. We can see the SQL code there in the middle. Select star from student records, which means print out everything in the table student records. To execute it, we need to tell our connection, I'm going to send you a command, and we call that creating a cursor. We send the command, and then we ask it, give me the result of that command. So cursor means I'm going to send you a command, execute it, runs it, and then fetch all means get it back. And then when we print out the result, we close the connection to the database. So I've set up a database, I put 3 records in it, I executed this code, and here's what I got. So what I got was, I ran the Python program, I would just put in 3 records. I put in 1 Joan Smith, female, that's the student number, and the date was, I put in the 9th of the 9th, 2013. The next student was John Smith, had that student number, and the date time is the year, the 9th of the 10th. And then the last student I put in was Joe Smith, male, and no student number, so I've left that as blank. And then I have the date time of 2014, September 1st. So that's what, if I say select star from the database, it just tells me all the records that are being stored in the database currently. So that's connecting to a MySQL database. So thanks very much. Over to you.